Dear learners, this is Dr. Shiva Daniel from the Department of Chemistry, Holy Cross College, Nagarkoil. In this video, I am going to explain about the topic Stereochemistry of Allenes. Allenes are organic compound having the basic skeleton CH2 double bond C double bond CH2. This is a simple allene. This allene having cumulated double bond. This allene is optically inactive because the groups present in the terminal carbon atoms are same. So it is planar and having no and is optically inactive. This is the structure of the simple allene having two double bonds. So this is another example of an allene. In this allene is optically active provided that the groups present in the terminal carbon atoms are different. This is one terminal carbon atom and this is the another terminal carbon atom. So in this terminal carbon atom, two different groups are there, chlorine and hydrogen. Here also two different groups, chlorine and hydrogen. And these type of allenes are optically active. So this is the another example. In this allene, this terminal carbon atom having A and B and this terminal atom having C and D. So the groups present in the terminal carbon atoms are different and this allene is optically active. Then reason behind the optical activity of allenes. The optical activity of allene was first explained by Van Hoff in 1875. According to Van Hoff, allenes are optically active due to restricted rotation. Allenes having two double bonds. Because of that two double bonds, the rotation is restricted and the groups present in the terminal carbon atoms are not in the same plane. Then later, the reason for the optical activity of allenes is explained by molecular orbital theory. So according to molecular orbital theory, allenes having two types of carbon atom, that is two terminal carbon atoms and one center carbon atom. So the terminal carbon atoms are sp2 hybridized and the center carbon is sp hybridized. The center carbon atom having two vacant p orbitals. These two vacant p orbitals overlap with the p orbital of the terminal carbon atom and forms two double bonds. And these two double bonds are perpendicular to each other. Because of that, the groups present in the terminal carbon atoms are also perpendicular and hence this allene is optically active. So this allene is having no plane of symmetry or center of symmetry and it is optically active. So this is the reason behind optical activity of allenes. So these are some examples of optically active allenes. So here in the first one, this is the terminal carbon atom and this is the another terminal carbon atom. So here the groups present in the terminal carbon atoms are CH3 and hydrogen. These are different. Here also it is CH3 and hydrogen. This allene is optically active and it exists as enantiomers. That is, they have object mirror image relationship. The object and the mirror images are non-superimposable. So it is optically active. So this is the another example. Here also the terminal carbon atoms are the groups present in the terminal carbon atoms are different and it shows optical activity. And these are some other examples of optically active allenes. So here in this allene, the specific rotation is minus 30.7 degree and here it is plus 30.7 degree. So these are enantiomers and exist as object and mirror image. They are not superimposable. So here for enantiomers, the specific rotation, the magnitude of the rotation is same, but the sign is different. So here it is minus 30.7 degree and here it is plus 30.7 degree. That is the enantiomers having different sign, but the magnitude of rotation is same. And this is another example for optically active allene. And this one is another example. And here, this is the object and this is the mirror image. They are not superimposable and it shows object mirror image relationship. They are enantiomers and this allene is also optically active. Hope you understand about the topic, that is stereochemistry of allenes. So we will Meet again with the next module. Thank you.